our objective on this experiment, linear motion, is 1. To investigate the relationship between force, mass, and acceleration. 2. To determine the acceleration of an object under a varying force.
One of the most basic movements is linear motion, or straight line motion that represents it as an object going along a certain path. Linear motion is a primary idea in physics. The study of linear motion helps us to understand the way objects move and interact with forces in their environment. This experiment will be based on key equations of linear motion, which are distance, the total length of the path that was traveled by the body, velocity, the rate of change of displacement with respect to time, which is v equals to d over t. And lastly, acceleration, the rate of change of velocity with respect to time, which is given by a equals to v minus u over t. The apparatus for this experiment are air track rail, blower, pressure tube, gliders, flag, photo gates, masses, mass hanger, string, and pulley.
The linear air track set was assembled as shown in figure 4.3. The pump was switched on and the air was let to blow through the track for several minutes. The track was balanced by adjusting the screws on the legs of the track so that the glider stays stationary and does not glide to either end when let go. One hook was inserted at one end. A flag was inserted on top of the glider. The mass of the glider and the mass of the hanger were measured and recorded. Then, the length of the flag was measured. One end of the string was attached to the hanger and the other end to the glider. Masses with a mass of 20 grams on the hanger and 80 grams on the glider were placed. The string was put over the pulley. The glider was positioned exactly before the photo gate. The glider was released and the time shown on the photo gate was recorded. Step 7 was repeated 2 more times to obtain the time average values. Then, the slotted mass on the glider was decreased by transferring a mass of 20 grams onto the hanger. Steps 7 and 8 were repeated. This procedure was repeated 3 more times with 20 grams from the slotted mass on the glider added to the hanger.
These are the examples to plot a graph of weight force versus acceleration. From the graph, the acceleration A is directly proportional to the weight force F. This is in line with Newton's second law, which explains the formula for force F equals to ma.
The gradient m of the graph is 8.95 times 10 to the power of negative 3 kilograms. The uncertainty of the gradient, delta m, is 2.14 times 10 to the power of negative 6 kilograms.
The relationship between gradient m from the graph and the total mass, Newton's second law explains the formula for force F equals to ma. From both the graph and the formula, the gradient is equal to the mass of the object, mt in the experiment.
The percentage difference between gradient m and mt in this experiment is 97.1314%. The factors that have contributed to the errors in this experiment are parallax error and air resistance. For parallax error, incorrect reading of the apparatus, especially when measuring the length of the string and weighing the hanger, contributed to the large percentage error of difference between the gradient m and the total mass mt. As for air resistance, although the track is frictionless or has low friction, drag can still slightly slow the object down. A few ways to overcome parallax error is having different observers to read and view apparatus reading and equipment to make sure the reading and measuring technique of each observer is correct, as well as differences in reading and measurements are minor. To reduce the effect of air resistance, we can reduce natural and artificial air currents by switching the fans and air conditioners in the laboratory off, as well as closing all or some windows close by the area in the laboratory the experiment is taking place.
In conclusion, by using a linear air track, this experiment demonstrates how Newton's second law of motion works. This experiment indicates that the acceleration is dependent on the mass to increase the overall tension, despite minor challenges such as parallax error and residual air resistance that affected our results. But we will still manage to get the results that align with Newton's second law.